Let's do some guided practice with section 3.4, the sandwich theorem. Remember, we're using this theorem to find limits with trig functions. So remember, we always start off by identifying the trig function, and then we keep adding on to it until we have our whole function, and then we also have the lower and upper bounds. So in the case of sine of 3x, we know that regardless of what's inside the sine is bounded by -1 and 1. So that's where we start. And where we finish is when we have this whole thing in blue highlight. All right, so anyway, since we have that 3 there, we're just going to multiply all three sides by 3. Then we're going to add 5 to each side, right, to finish off that numerator. Right, and then 8, right? So it's bounded below by 2, bounded above by 8. And then we're just going to divide both sides by 2x, or rather I should say all three sides by 2x. Make that a little neater. Right, and just to be clear, this equals 4 over x. Just to be clear, this equals 1 over x. And at this point, we just need to note that the limit as x approaches infinity of 1 over x equals 0, which also equals the limit as x approaches infinity of 4 over x. And so then we always say, right, and that's good. We need them to equal each other. So we always say by the sandwich theorem, because we haven't actually answered the question, we haven't actually found the limit. The limit as x approaches infinity of 3 sine of 3x plus 5 all over 2x equals 0. And next one's going to be somewhat similar, maybe a little different. Right, again, we have our trig function right here. We note that cosine is, of course, bounded by -1 and 1. And then we multiply by, you can say by -4 is what we're really doing, but the inequality is going to be the same. Right, it's still going to be bounded below by 4 and above by 4. It's not bounded above by -4, right, because you're just flipping the function. So negative values will become positive, positive will become negative, etc. Anyway, we're now going to add x cubed, and I'm going to go ahead and add it on the left side here, just to make things look a little bit nicer when we have to take limits. Yeah, I'll just do it that way. And then I'm just going to divide by 2x cubed plus 1. Okay. And at this point, I know that I'm done because I have the same function here that we started with. Okay. Anyway, we have to show that the limit, I'll do it in blue so it pops. The limit as x approaches infinity of x cubed minus 4 over 2x cubed plus 1, well, that's going to give us infinity over infinity, never what we want. So we're going to have to multiply the top and the bottom by 1 over x cubed. And then we get limit as x approaches infinity of 1 minus 4 over x cubed divided by 2 plus 1 over x cubed, and we get 1/2. And note that that's the same thing as if we did the limit as x approaches infinity of x cubed plus 4 all over 2x cubed plus 1. In fact, it's so similar, I'm actually just going to go ahead and really duplicate this whole thing. Right? In fact, actually, let me even just erase all of this. Erase, erase. And really what I can even just do is, I'm cheating a little bit here with the iPad, but I'm just going to change this into a plus, plus. And the answer is exactly the same. And so then we just have to say, by the sandwich theorem, the limit as x approaches infinity of -4 cosine plus x cubed all over 2x cubed plus 2x 1 equals 1/2. Okay. Last but not least, so that involves e to the x, and that's a little weird if you don't know what e is, but you can just pretend that it's the number 3 if that's weird. But anyway, we start off the same way, right? We just say cosine is bounded below by -1 and above by 1. Now, we multiply both sides by e to the negative x. Now, at this point, we need to know that e to the negative x is the same as 1 over e to the x. So we're really talking about this. And I'm just going to rewrite it like this because I think it's a lot easier to visualize. Right? And again, thinking about e to the x, it's some positive number to x that's blowing up. So what happens as x gets bigger? It's going to be 0. Just like the limit as x approaches infinity of 1 over e to the x. And so last but not least, we just say by the sandwich theorem, the limit as x approaches infinity of e to the negative x cosine of x, cosine of 5x equals 0.